Hello and welcome. My name is Frank Fischer, and in this Nibble I want to talk about something that we see super often in React projects out in the internet. So here you have an example for this. Here's another one. There's another one. And it's more or less always the same thing. It's about how React components store their state and how the state needs to be updated. And that the complex element within these states are actually a bit special and you need to be careful to update them. Or as my colleague Dr. MC Hammer says,
Yo, I told you, you can't touch this. Why you standing there, man? You can't touch this.
to show you what I mean, I developed a little application here that has this bug, and we can easily focus on how the bug works and how we can get rid of it. So what we have here is this application. It's actually a little pocket calculator. So you can have numbers here. You can add these numbers. You can divide and stuff like this. And what you see up here is the history of the commands you've given. And here, down here, you can enter numbers. On the right side, you see the debugging menu of Chrome. And what I want to show you now is these are actually two components inside of a bigger component. So there's a wrapper component around them. There's a number entry component, and there is a history component. As long as I enter numbers here, there's no need for the history component to do anything. Only if I start to do something, it should kind of kick into action and re-render itself. If I now go here into this history component and I make a breakpoint to see how often it literally re-renders. So let's go in here and let's do this. You see that whenever I press a number, it actually re-renders. That is not necessary. So with this, we obviously waste performance. So there is an opportunity to optimize the performance here. So let's see how we can do this by looking in the source code.
Break it down. Stop. Hammer time.
So this is the source code of the demo application. As you can see, Visual Studio Code here. We have a React application, and this is the app component of this React application. And you see we are just using one component here, which is Pocket Calculator. If you're looking into Pocket Calculator now, let's go to the render function here. You see we are using two subcomponents, Pocket Calculator History and Pocket Calculator Input Bar. We're using the React props mechanism to communicate data, you see here, as well as communicating callback function to this container component, so that these subcomponents are actually more or less pure. They don't have their own state, and they have the state centrally hosted in this container. So if we go up here and look into the constructor, we see here's the state object generated, so current value and a history array with history entries. If we enter anything in the text box, this is the input change that is then called. You see we're checking if this is really a number, and if so, we're accepting it as the new state. And if a command is pressed, we're actually jumping into this function. And as you can see, it's a switch case where I look what kind of command was pressed, calculate the new value, and then update the history as well as the current value accordingly. So yeah, sorry, no JavaScript eval function or something like this. Quite easy little parser that we have here. So one thing we already observed was that the Pocket Calculator history is actually rendering very, very often. And this happens because it's a React component. It's not telling React that this is actually a pure component. So if we say here it's a pure component, we are giving React the idea that this one doesn't have its own state and doesn't do anything in changing the environment. It's just rendering things. Okay, so we save this and we have a look now here in our app demo application. You see here's our breakpoint. Now let's type some numbers in, and you see we are not re-rendering the thing the whole time. But oops, what happens here? We're not rendering at all anymore, it seems. I would expect that whenever I do a command here, then we have a new entry in the history and we should see it here. Okay, maybe the history is wrong. So let's have a look into Pocket Calculator, and you see here is the point where we update the history. So let's do the following. We're setting a breakpoint here. and we are adding something to the history, and then we are looking into the history, and we see, no, the history looks actually quite good. So all of the commands that we have are actually on the history recorded, and we're using the setState to update the history. So something is fishy there. Let's have a look.
Break it down. Stop. Have a time.
So back in our source code, in the Pocket Calculator source code, here is the code that is responsible for setting up or for updating the history. And you see, this is a construction you see super often. So what we're doing is we are using a deconstruction to get the history. It's an array, the history, out of the state. Then we are pushing a new element on this history. And then we are setting the state by using history. And by the way, the current value is also then empty because we calculated everything. So this is a construction you see super often. And if you hover over it, you see that here is the message, the suggestion that DeepCode comes up with. And this is the exact same one that we saw already in the web front end. And it says that there's something with undesired behavior, other state updates might be badged, and the push modifies an element of the state. So with this, we are modding an element of the state. But here we got it from the state. So what is the thing behind here? And I think to understand this, you need to know what is shallow copy. InfoBox, concept of shallow copy. Given we have an object with a property of a complex type, such as object or array, if we assign the object property to another object property, in reality, only the reference is assigned. The object behind is the same. So changing it from one side will change the underlying object. Most of the time, this leads to unwanted effects like race conditions. With ECMAScript 15, the spread operator was introduced. So using this construction will actually copy the object. But be aware, this is only one level deep. So nested objects are not copied but referenced again. To overcome this, aka deep copy, there are libraries available. End of InfoBox. Aha, so now that you know what shallow copy means, let's review what DeepCode is suggesting us here. So DeepCode says React component state should only be modified through setState. The call push modifies an element of state. This could lead to undesired behavior, and we will see what this means. Okay, let's have a look. So this is a construction you can see all over the web. You see it in use in millions of repos. We literally found tens of thousands of repos using this. So what we do here is we have the state object. We are deconstructing the state object into this history. So now we have the history array here. But as you know now, this is literally the same history array as it is in state. So it's the same thing. It's just a new reference that we have here. What we do then is we are pushing onto this history array, which is the one in state, a new line. And then we are calling setState with this history, which is, by the way, the same history that's already in the state. And we are also setting current value to be empty. This is bad out of two things. So number one, we are taking away the chance from React to kind of understand which elements of the state were literally updated and which not. React would need to kind of dig into the whole state and look what are the differences. And it cannot do this, because there is no more information left over. You change the state itself. So this is the reason why we have this rendering problem. Another problem that comes out of this is when you look into the React component here. So this is the documentation on the React component on the function setState. And you see here they are explaining that setState is actually asynchronous and it can batch up multiple calls to use one cycle to update the state accordingly. So if you access this state directly, it might be that it's actually, depending on where you are when in the life cycle of the component, it might not be current information anymore. So because these batches are not executed, the state is actually outdated. And this is a bug that is super hard to find. So, okay, now we know how we don't should not do it. So let's see how we should do it. So let's get rid of this one first. Toggle it out. So there are two ways for us now. I want to show you both of them. First, the one that is kind of okay in our scenario here, and then the one that is kind of the best way of doing it. So okay in our scenario is this one. I won't untoggle it. I need the rest one here. This one is okay-ish. What do we do here? We are actually using this new functionality from ECMAScript 15 to get the history array unrolled into this empty array here, and then we are adding a new line at the end of it. And with this, we're actually having a new history array now, which contains the old history array, but a new line. With this, I treat the history within the setState as an unmutable variable. So I'm not changing history in place anymore. And then I can call setState history, and it will work accordingly. One problem that might arise here is, not in our scenario, but in other scenarios, is it still might be the problem that the state is not valid anymore. You know, that there is the batching of state changes, and we would use a poisoned state. So the actually best way to do it is this one. Let's untoggle this and see what we're doing here. And what you see here is I call setState, but I hand over a function to setState. And the function has a state argument and a props argument. I have the props in here just to show you. I don't use it in here, but I just wanted to make sure you understand. So you have access to both of them. Within this function, this state is giving me a state that I can rely on. So I can literally say this state is something I can use to calculate my new values. These are props I can use to calculate new values. And then I can literally save these values by returning a new state out of this function. So as you can see, we are constructing a new state here by setting up a new history array. We are unfolding the history as it was in this state element here. We're adding a new line to it. We are setting the current value to empty, and we're handing over this object, which becomes the new state. And in this function, I can be ensured that React takes care of setting up the state variables and stuff accordingly. So let's save this, and let's see how our React app is reacting to this. Okay. So here we have the React app. Now we enter something, and you can see it works exactly as we would like to work it. And this is exactly, you know, the behavior that we want to have. So what I wanted to show you is the wrong way, you know, obviously, that you can handle state, the better way of handling state, and the best way if you need to, so to say, use old state history data, or the old state or the props, to calculate the new state. So I hope there was something in there for you. I hope you learned something, and I hope I see you next time. Thanks for watching, but now it's your turn. Go to deepcode.ai and check out what DeepCode can do for your code.